Thanks for joining us for this webinar on modeling Luminit's Light Shaping Diffusers in OpticStudio. My name is Akash Arora. I'm the product manager here at Zemax, and today we've got Anthony Ang of Luminit who's going to be presenting some really interesting stuff about Luminit's Light Shaping Diffusers, and he's also going to be talking about a DLL that they wrote to model their light shaping diffusers in OpticStudio. Before I turn it over to Anthony, I just want to mention that after the live webinar, we will have a question and answer session that both Anthony and myself will be answering questions during. So with that being said, I'd like to turn it over to Anthony.
Thank you, Akash. Hi, everyone, and thank you for joining us today. Okay, so I have a BS degree from University of Laverne, and I'm responsible for generating holographic masters, optical design analysis, and diffuser model development. Previously, I worked for Newport Thin Film, Xerox Corporation, and Autologic Information International. I filled various technical, engineering, and management roles in the areas of thin film coatings, laser scanners, and holographic diffusers. Okay, here you can see a representative of where Luminit plays in industry. We have architectural lighting. We're in architectural lighting, automotive tail lights, avionics, AR and VR, HUDs, and CGHs. We were founded 10 years ago, and Luminit is expert in light management solutions for our customers. Our core technologies include holography, surface structure replication, and high volume manufacturing. Okay, so our commercial products involve light shaping diffusers and prismatic films. So today we'll be going over light shaping diffusers. So the key benefits to our light shaping diffusers involves hiding individual LED sources. We have precise light shaping capabilities with a wide selection of angles from circular to ellipticals. We provide high uniformity, both spatially and chromatically. We have many substrates, such as polymers and glasses, and many comes in many formats. So we have sheets, cut parts, injection molding, and rolls. Okay, so why choose Luminit? So as far as performance is concerned, we have good control of light shaping. We have a large variety of angles and formats, excellent hiding power, and transmission. As far as our technology is concerned, we have patented positions in seamless roll-to-roll manufacturing, injection molding, and we have customization as well as high temperature glass diffusers. So thank you for listening to our sales pitch, and we'll go to the next section, which is our technical section. So if you look at the picture to the right, it is of a holographic diffuser, which is a pseudo-random surface relief microstructure. As opposed to etched or ground glass diffusers, light generally strikes a surface only once in order to scatter. So this provides a high rate of transmission. The pseudo-random nature produces a very uniform wavelength properties. So we found that our customers needed some type of modeling, and so we provide many different formats. You can go to our website and look at that. We also have modeling services that we can provide, but today I'm here to really talk about and demonstrate our new model, and this will be provided to Luminit users. Okay, so here's a couple of definitions, but I'm not going to read the whole thing. Basically, what I'm saying is that industry has a term, BSDF, which stands for bidirectional scatter distribution function, and it's a very general term used. However, distinct that from Zemax also has a BSDF and is a very particular scatter function. So most of the time I'll be talking about the Zemax BSDF. So this is how our scatter model works. So in Zemax, there's a user-defined type of scatter model. That's what you'll activate when you use our model. So it is a proprietary function. In other words, the base is the user-defined type, but we wrote our own code. And it scatters the light statistically, and it will shape the light so that it will emulate our product. So the model works on a surface of a volume. So you have to have a volume object and indicate one of the surfaces to be your scatter surface, and that's how you have to bring up our model. So it also allows you to select from a catalog set of values. So you can't do it right directly from that model, but we'll provide catalog values at the end of this slide so you can see what numbers you can insert into the model. Okay, so as far as file format goes, this model becomes DLL. So it basically, speed-wise, it is going to be as fast as possible. The file exchange is going to be very fast within Zemax. If you look at the Zemax BSDF, it is a table of values. It is also very fast, and it is, if you'll see the next slide, I'll show you later, but it's text-based. Okay, so it's probably not as fast, but still going to be plenty fast. I've tried it before. Okay, there are other types in Zemax which are written in C++. As far as level of freedom, you can enter in our most popular angles, which will be in the catalog at the end. In the BSDF type, each file provides only one type of product, one angle. The other Zemax types, in general, you can enter in parameters which you can change the size of the distribution, except for the Lambertian. Lambertian is, by definition, only one type of distribution. Okay, as far as scatter types, Zemax BSDF is a surface type of scatter. The other types in Zemax come in both varieties of surface or volume. Ours is pretty particular type, meaning that you have to have it associated with a volume, but it is a surface scatter. Okay, so now we're ready for the video.
Hello, my name is Anthony Ang, and I'm a senior optical engineer at Luminit. Luminit's LSD scatter model is the idealized scatter BTDF of our product line. In Zemax OpticStudio, the user-defined scatter function is written in C++, compiled, and formatted as a DLL file. Scatter as a function is available only on professional and premium editions of Zemax. We can model Luminit's circular and elliptical LSD angles. Only our catalog angles are enabled. For calculating transmission, light is treated as randomly polarized. Please keep in mind that TIR, coatings, curved surfaces, and polarization are not enabled in this model. Once you've downloaded the file, place the DLL in the following location: C, Program Files, Zemax OpticStudio, DLL, and Surface Scatter. Once the files are in place, open Zemax OpticStudio. Make sure you set it in non-sequential mode. Then select the source and detector of your choice. I have selected the polar detector for this example. Now create the object which will contain the LSD. Select the Object button. Select your object, such as cylindrical volume. Press the View Current Object icon. Then go to the Coat Scatter option. Select the surface or face in which you will apply the LSD. I'll choose the front face. When the face turns orange on the view of the current object, you can tell which surface that you are on at this point. For the scatter model, select the user-defined option. Now go to the DLL name and select the correct file. Here it's Lum LSD B3. Now, this is very important, select the scatter fraction to be 1. Then select your LSD angles in the X and Y directions. Make sure you hit enter, otherwise the number might not be what you think it is. Just like our products, the X and Y angle indicators indicate full width half max of the angle in degrees. Now you can close the window. Make sure that your object is larger than your ray set. Next, adjust the size and settings on your object and or source. In order for the scatter to work, you must assign an optical media to the volume object. Click the cell which contains the object and materials. Now type in PMMA. Click yes. Now the object is ready to go. If you want to see the scatter in the NSC shaded model, select the down arrow on the upper left hand corner of your NSC shaded model. Then select Scatter NSC Rays. Check the box and hit OK. If you don't see the rays scatter, you may have missed a step, such as the number of layout rays. By default, when you indicate a new source, it usually starts at 0. Now to trace rays, go to Analyze and click the Ray Trace icon. Select Ignore Errors and Scatter NSC Rays. Now click Clear and Trace and wait for the trace to finish. Once the tracing is done, you can click Exit. Now you can analyze the rays in the different views. You can look at it in false color, or you can look at a polar plot, or you can look at it in a slice. Now let's try a different angle, such as a 50 by 3. Just go back to your object, go into the coding and scatter, and change the numbers for the diffusion angle. 50 by 3. If you enter in the wrong numbers, you may get a null result. In other words, let's try 4 here. So you could see that there's no scattering occurring. So only 50 by 3 and other catalog angles will work. Now let's trace the rays. Okay, now exit. As you can see, now we have a 50 by 3 elliptical diffuser angle. You can see that we definitely have a much different aspect ratio for this than the circular diffuser. Here are some important tips to remember. You have to make sure you have the correct source parameters for your system. Next, make sure you have a high number of rays to get a good statistics of the spread, from about 10,000 to 100 million depending upon your patients. Make sure that your scatter fraction is set to 1. As far as your object parameters are concerned, make sure that you have a volume type object. Make sure it's either cylindrical volume, rectangular volume, a standard lens, or others that have volume to it. Next, make sure your material is either PMMA for standard diffusers or BK7 for a glass diffuser. And finally, make sure in your analysis section, check the NSE scatter rays on a checkbox. Thank you for watching this video. We hope our model will help you in your design process.
Okay, I hope that was very instructional for everyone. Right now, what we have here is goniometer readings, which is measurements of our diffuser performance. So I have between 1 degrees, 30 degrees, and 60 degrees. What you can see here is that our 1 degree to 30 degrees is basically a Gaussian shape. As you migrate higher than 30 degrees, you'll see angles, not angles, but distributions that migrate away from Gaussian. So this is our model. So you can see that the shapes of the model also are very close to our measured values. So this is what I'm talking about when I say it emulates our product. And you can see on our models also that the Gaussian shape is there for 1 degree through 30 degrees, but as you transition away from 30, it starts transitioning away from the Gaussian profile. Okay, here we have readings from 60 degrees, 80 degrees, and 100 degree diffuser. As you can see with the 80 degree, it looks more trapezoidal in shape, and with the 100 degree, it looks more like an M shape. So you can see the emulation is not perfect, but is close enough to what we have in measured values. So this is what we provide when we provide this DLL files. You can access many different shapes and angles from Luminit's library of catalog values. So here's a demonstration of if you indicate the diffuser on the first side of the object or the second side of the object. As you can see with the 40 degree, it's slightly off of Gaussian, but if you put it on the second side, it's going to look skinnier and pointier. And so this happens in reality with our products, is that if you hit the surface with the light first, it behaves differently than if you flip the object around and you hit the light on the second side of the object. Here you have a 60 degree, it's a circular diffuser, however the light's coming in at a high angle, at 60 degrees angle of incidence, and you can see there's asymmetry starting to form here. It's not only elliptical from the 2D plot, but if you look at the slice plot, there is asymmetries there also. So this happens in reality with real products. This is also a very exciting development. With highly ellipticals, you see here there is a bend in the profile, and that happens with real products. So if you get a hold of some of our samples and you get a highly elliptical, you can try this with a laser beam. Shine a laser beam at a very high angle, and you can see there's going to be a bend to the light that comes out. So here's our catalog values. We've provided 13 circulars and 14 elliptical angles, and those will be on one file, and a separate file will be provided for the glass type. So there's 9 different circular angles. So you can go to our website and go to where it says DLL downloads, and you'll find these available. We also have instruction set in case you forget what happened during the video. Everything is in there in a knowledge-based article. Also, Zemax will also have a knowledge-based article showing the same thing. So in summary, Luminit has a large number of different angles you can select from as far as our product is concerned. And also, you have LSD model now that you can use to simulate the performance of our diffuser in your system. Okay, so Luminit is making this model available to you. Right, so some model limitations. So the BTDF, which is the transmission portion of the BSDF, it has no reflection, just transmission. Only your catalog angles are available, and rays will propagate only in the forward direction, in other words from surface 1 to 2. If you flip the object around, it's still from surface 1 to 2. TIR will not work, and polarization of the light is treated as random. coatings will not work, and curved surfaces will not work properly. All right, so on to our Q&A portion.
Thanks very much, Anthony. That was very helpful. If your questions don't get answered, or if you have questions that arise after the webinar, feel free to email either support@zemax.com if the questions pertain more specifically to OpticStudio's capabilities. If the questions pertain more to Luminit's diffusers or their DLL model, sales@luminitco.com would be the appropriate email address. Okay, so looks like we're getting some good questions here. Anthony, I'll present the ones that pertain to the light shaping diffusers and to the DLL that you all wrote for you to answer, and if there are any that pertain to OpticStudio, I'll answer those. So I'll just go down the list in the order in which they came in. The first question is, what is the impact of volume thickness? I presume he's referring to when you use this DLL in OpticStudio, what's the impact of the thickness of the volume?
Okay, in reality, with real products, it doesn't really have much impact unless it's an absorbing media. So typically in OpticStudio, most of the media is not absorbing. So I believe the impact is almost nothing. However, what I would do if you have media, let's say plastics that are other than PMMA, is put a thin layer of PMMA on top of, let's say, polycarbonate, because polycarbonate does behave differently in terms of how it refracts. So there'll be slight differences, but in other words, transmission should not really be impacted, or even the light distribution.
Okay, next question. What if the diffuser is moving?
Okay, as far as the model is concerned, I don't know if you could do that in the model, but if the diffuser is moving as far as a real item, as long as you keep the plane of the diffuser the same, in other words, the location of the surface of the plane, and there's no power in the substrate, let's say, it should, in general, what we have is a little bit of spiky looking diffuser. If you saw the plots, in reality there's a little bit of spikiness. The spikiness will smooth out. So you'll still see a little bit, but not as much as if you just kept the laser beam still on the surface.
All right, next question. One moment here. Which angles of incidence range work properly?
Okay, so as long as you're, let's say, coming in from negative Z to positive Z direction of the object, as the object is in its initial location without prior rotations, it should be fine from anywhere from 0 to almost 90 degrees, as long as you can intercept the rays. Okay, but if you rotate your object, you also have to rotate which ways the rays come in.
Okay, next question. I assume it emulates the far field. What about the near field?
Okay, as far as near field is concerned, we didn't really test that, but if you see that if you put a single ray in, or a single direction and location of rays in, as far as the randomness of the software, it will continually change the direction until the full distribution of the light is played out. So as far as the model is concerned, it will change the direction for every single ray. However, in reality, it doesn't really behave that way, because it's a physical product in which a single ray would behave the same way every time.
All right. Next question. If my incident light isn't collimated, how well does your model predict the result?
So if you look at how I came in with high angles, yeah, the model should be very good. It should be able to handle any kind of incidence from 0 to near 90 degrees.
Okay, next question. Do the Luminit models work on curved surfaces and also in the presence of TIR?
Okay, as far as curved surfaces go, this model will not work properly on it. Basically, they'll treat it as if the surface was normalized to the Z direction. Okay, so the normal pointing in the Z direction. So it won't even consider the surface as if it was curved. It would think it's a flat surface and go straight through. The light rays would go straight through. As far as TIR is concerned, it will create some kind of defects, so I recommend not trying TIR through the system. If you enter a flat and another flat, which are parallel to each other, you should be fine because you shouldn't really create TIR conditions in that case.
Okay, next question. Do you have a top hat shape diffuser model? So I'll present that one to you first, and then there's a second part of that question, but I'll wait for you to answer that one. Do you have a top hat shape diffuser model?
Yes, our products do not have a top hat shape, so basically none of these models emulated will not also have, or how did I state that? They will also not have top hat shape. So they're either Gaussian or transition to what you saw trapezoidal, but not quite top hat, and become a M shape at 100 degrees.
Okay, and then the second part of that question, what is the laser damage threshold for your glass diffuser?
You'll have to go to the sales site because I didn't memorize that value, but you can ask them. We have a few different glass diffusers, so depending upon which grade that you buy, they have different thresholds, but our highest thresholds will in general be the same as the substrate. So it's very similar to BK7s.
Okay, next question. Is the transmission modeled properly whereby it varies with angle of incidence?
As far as that goes, I try to make it as close as possible, as long as you got to consider that the light is randomly polarized. So I'm not going to consider it if it's polarized with any specifics, but I'm going to treat the light coming in as randomly polarized, and I'm going to treat the transmission with respect to it as a randomly polarized light.
Okay, just a couple more questions here. What will happen if the incident light is white light?
Yes, it can handle white light no problem, as long as the media, such as the, let's say, PMMA or BK7, whichever one you indicate, has indices referred to within the code. It can handle the wavelengths available to those index values.
Okay. Does the model take into account the wavelength of the incident light?
Yes, the model will take into account the wavelength of the incident light.
Okay. Does the grain or texture of the diffuser change with Luminit's angle specifications? Do you have a smooth diffuser? Is the grain or texture part of the model?
Okay, in our real products, our grain does change with different angles. However, in this model, it strictly geometrically follows what you bring in, which is a perfectly flat surface. So the model just mathematically changes its direction. So the model is absolutely smooth. The product has some texture to it.
Okay, how short in the UV wavelength can these diffusers be used?
Let's see. I haven't really tried it myself, so I wouldn't know how short you can go. But if in the model themselves, if you look at the index, if there's index down there, then you can use that model. You could try it out, but I haven't had a case where I needed to do it myself, so I think you would have to really try these out yourself.
Okay, last couple of questions. Will the model work with other substrates, for example, fused silica?
Yes, the model will work with other substrates. What I recommend is if the index of the model that you're putting in varies too much from, let's say if you're doing a plastic diffuser, if it deviates a lot from the PMMA, I would indicate a separate substrate and put a thin layer, very thin layer of PMMA on top of that. If it's glass type, you can put whatever model substrate in and put a thin layer of BK7 as your diffuser.
Okay, one more question and then I think we'll wrap it up here. Does the model take into account the edge of the diffuser?
I don't quite understand what they mean by edge of diffuser. So,
Anthony, they may be referring to if there's, you know, at the edge of the diffuser, if there's some sort of, you know, distortions due to your manufacturing process. That's probably what I would infer from that question.
okay. Yeah, the model will not treat the edges any differently. It doesn't know that there's different things happening at the edge, so it'll just treat the whole surface, whichever surface you indicate, uniformly throughout. One other thing I just want to say before I go is that if you have a little trouble importing the model, let's say due to if you have any antivirus software stopping the download, just go to the sales at Luminit Co. and they can help you out. We can send you an email of the models.
Okay, so we'll go ahead and wrap it up there. Anthony, thank you again for participating. Again, for those of you that are watching this webinar, if there are any additional questions you have, as I said before, feel free to contact either Zemax or Luminit at the addresses here. The recording of this webinar will be posted to our website within a few days. So if you have any colleagues or friends who missed the webinar that would like to watch it, they will be able to see it on demand. So we thank you for attending this webinar, and we look forward to seeing you at a future webinar.